Hello everyone. In this video, I am going to explain an agent-based model which was done in AnyLogic. In this model, we are trying to explain the different states for a group of employees working at a specific company. An employee can be sick or not sick. So if the employee is sick, this means that he or she should be making a quarantine for a specific period of time, or they can be working in a working status, either by being out of office, in office, and when they are in the office, they can be taking a break for a specific period. After finishing the break, they should be going back to work, and after spending the normal working hours, they will be going back home. So to model this problem, we define several parameters. In this case, I will start by the time variables. In this arrival time, what we are saying here is that each individual, I will just start saying individual or agent instead of employee because this is an agent-based model. Each agent can be coming to the office starting from 8 to 11 a.m. Whereas in the leaving time, an agent can be leaving the office from 4 to 7 p.m. And for the arrival time and the leaving time, we are using a uniform distribution, a random value from a uniform distribution. And the same case for the break time, but instead of using a discrete value, we are just using the continuous uniform distribution. And this break is again a random value from a uniform distribution with a lower bound of 7.5 minutes and 30 minutes. And the other important parameter here is the quarantine time, and this is basically the time an agent will be taking or will be in the sick state, and this is 120 hours, which is equivalent to 5 days. These two events of changing the value of the other two variables. The hour of day is just getting the runtime and assigning this to this variable, whereas the other event is assigning a random value to the COVID patient or the COVID infected variable. And this value is at a random value, of course, and this is a value that is either 0 or any other value. So if an agent is assigned a 0 value for the COVID infected variable, this means that he is not sick. So he should be passing through these different states. But if an agent is assigned any other value other than 0, this means that they will be in the sick state. So let's take a look on this model. So as you can see here, this is the runtime, which is basically representing the time of the day. And before we didn't reach 8 a.m. yet, we will have most of the agents in the out of office state, and some of them were identified to be sick. And this will be the case until we reach 8 a.m. And at 8 a.m. we will see that some of the agents will start changing their status from out of office to in office by changing the color. And this will be the case until we reach 11 a.m. At 11 a.m., there's a minor delay between the timer and the animation, but as we saw, once we reached 11 a.m., we saw that all of the individuals or all the agents were, of course, except these 4 because they are already sick, were changed to green. This means that they arrived to the office. And after some time, we will see some of these agents are taking a break, so their color changed from green to yellow. So this will be the case until we reach 4 p.m. We will see that some of them started to leave, and this will be the case until 7 p.m. We only left with out of office and sick agents. After we complete the first day, we will see more sick people start to appear, as we saw here, these two. So the same cycle will be repeated until we see that the sick people will be increasing day after day, because what we are actually having is some sick people or some sick agents taking a quarantine and new sick people are appearing. And this will be the case until we reach the quarantine period, which is 120 hours. If we still remember the agents that were initially sick, once we started this model, we will see them moving from being sick to being well. So for example, I remember that these two were initially sick. So once we reach 120, we saw that these two agents specifically changed their status from sick to not sick. To explain this better, let's see this time stake chart. So in this time stake chart, the x-axis shows the simulation time, while the y-axis shows the number of employees in each state. Again, the green is in office, yellow is taking a break, red is sick, and lavender is out of office. Initially, we started with this number of agents sick. Once we reached 8 a.m., we started to see the people arriving to the office. They will be arriving until 11 a.m. Some of them will take a break during the day, as we can see here. And once we reach 7, all of the working agents will be at home. So we will have them out of office. And we will see that once we reach 24 hours, the number of sick people will increase, because we could have like new cases, for example, new COVID cases after each day. So this will be the case. We will see that the same cycle will be repeated, of course, with a different shape, because we are using random values for the number of people working and the number of people taking a break. So we will see that the pattern won't be exactly the same, but what we can see is the number of sick agents is increasing with time. And this will be the case until we reach 120, because the initially sick agents can be coming back to work from the office. So let's see how it would look like. Okay, so also after reaching 120 hours, we can still see an increase in the sick agents. This means that the number of agents that were initially sick and came back from the quarantine was less than the new sick agents, or the agents that were sick just after day 5. So we can see that at a specific time we can see a reduction of sick agents. I'm not sure when exactly, but let's see. So that was the case in day 8 or 6 or 7, because at this period the sick agents who became sick at this time period became not sick. So we can see a reduction of the total number of sick agents. If we kept running this, we will see that the pattern will be repeated every 24 hours with a small change or a small variation in the number of walking agents and agents in break. Thank you.